So here they are telling us this substance here called solubility of a salt. This might be our last lesson in salts. And then we shift, maybe look for another topic to deal with. But they are saying solubility of salts. Solubility is amount of a solute. Amount of a solute. We have a solute in grams. This amount of a solute in grams required to saturate. We looked at the word saturation. We have understood it. To saturate 100 grams of a solvent at a particular temperature. At a particular temperature. Now, if you are given, we looked at an example of sugar, salt, and then we have water. Someone, peace. Peace?
Yes, teacher.
Which one of these is a solute? Sugar, salt, and water. Between this and water, which one is a solute?
Salt.
Salt is a solute. Good.
Yes.
Who is quiet? Ready? Ready?
Yes, teacher.
If you add sugar to water, what is the end product?
You get a solution.
Solution. Thank you. So if you add the two, sugar and salt, the final whatever you get is solution. That means the whatever will be uniform. You will not be in position to differentiate between sugar and water. It will be like water, but if you taste, it tastes sweet. That's when you know that there's sugar here. If you put salt, it also gives you the other taste. And you'll know that this is salt solution. Good. So this one is a solute, this one is a solvent. So you must know the amount of a solute in grams required to saturate 100 grams of any solvent provided. That's when you will know solubility of that substance. Now, this one we described them earlier on. We know these salts. The salts is described soluble if it dissolves in a given solvent. Insoluble salts don't dissolve in any solvent, they just remain. We looked at these examples of ammonium, sodium, and potassium. All their salts are soluble. And all their nitrates. Chlorides, we have a few that don't dissolve. Silver, lead, and mercury, those ones. Sulfates, we looked at lead, barium, those ones don't dissolve, the rest dissolve. And calcium, that's just dissolve sparingly. All carbonates do not dissolve except the one of potassium, sodium, and ammonium. Those are the only ones.
Teacher.
Yes.
If you dissolve an insoluble salt, do you get any changes?
No.
Has any reaction?
There will be no reaction. If something is insoluble, can it react? It is like you getting sand and you put in water. What do you get?
Sand and water. I get sand and water.
If you add them together, do you get any solution?
No.
So that means that sand is insoluble in water. Okay? So let's look at this example. If you want to determine solubility of a salt, these are the few steps we take. Now, take about 50 cubic centimeters of water. So this is our solvent. This is our solvent. We are using water as a solvent. So if water is our solvent, we are going to add sodium chloride as a common salt. So now we are introducing a solute. Add a solute to a solvent. Little while stirring continuously until no more salt dissolves. That means the salt is saturated. The solution formed is saturated. Now weigh the evaporating dish. Weigh the evaporating dish. When you weigh the dish, the reason that's why we weigh the dish is we want to know the exact amount of the solute we have used or they have used, because here we are adding little by little. We didn't know how many grams we added. So we want to know the amount of this salt that was required to saturate water. So here they are saying power 50 of this, but when you're calculating solubility, they use grams, not the volume. They use grams here. Have you seen grams? Even here is grams. So not volume. So we are going to look at a particular number down here. That's going to give us a clear view of this. But here they are saying, while stirring it, this one was to saturate, weigh a clean evaporating dish, weigh a clean evaporating dish. Pour into it little of the clear salt, the salt we had here. We don't need the other undissolved salt. We need only that clear part, the one that was saturated, the one that was there is the one we want, not the undissolved one. So they are saying, then here they are saying, weigh the evaporating dish with the salt solution and evaporate the solution to dryness carefully. The reason why we evaporate, we know because we prepared some salts this way. We are trying to form crystals from the solution. Allow the evaporating dish to cool and reweigh the dish with the salt. Now here we evaporate to dryness. When we are forming salts by crystallization, we don't evaporate to dryness. We saturate it by evaporating to a point where crystals start forming. Now at this stage, we don't need the water in the salt. We evaporate to dryness. We want the exact grams of the solute used. Our solute is the chloride, sodium chloride. So here they are telling us that the results, the mass of the empty dish, if the mass of the dish is A, now the dish plus the saturated solution before you heat, it was B. Now this B has even the mass of it is both the mass of the dish and the solution, because after pouring, you weighed the mass of the dish and the saturated solution. Now here they are telling us after evaporating, the mass of the dish plus the dry salt was C. Now if it is C, they are just using letters, but we are going to look at a number that has clear view of this. Now if you are calculating the mass of the saturated salt, it's going to be, here it has 2. There is mass of the saturated solution and then mass of the dish. But you know the mass of the empty dish. So if you subtract this from this, you will be getting the mass of the solution, mass of the saturated solution here. If you subtract this, B minus this, you'll be getting that in grams. So the mass of the dry salt, if you want to get the mass of the dry salt, if you have the mass of the dish plus the one you evaporated, this is the mass of the dish and the dry salt is C. If you subtract the mass of the dish, which was A, you will be getting the mass of the dry salt here. So that is what you use now. Now, for you to calculate solubility, you need to get the mass of the dry salt, and also you must know the mass, which mass of the solvent dissolved this salt. So if you know the mass of the solvent, then you can get it. Now here they're saying mass of water or solvent is going to be this one, B minus A. What was B minus A? B minus A was mass of the saturated solution, isn't it? Yes? B minus A. was mass of the, we want mass of the solvent we used, not the mass of the saturated solution. From this saturated solution, we have the salt inside, and then we have what? The solvent also. So the mass of the water or solvent used will be B minus A, which was the mass of this, minus the mass of the dry salt that we got here. That one gives us the mass of the water used. So if you open these brackets, this is what happens. So mass of the dry salt we have known is the mass of the dry salt is C minus A. Now, here they are saying if you open up the brackets that the mass of the solvent is going to be mass of the solute, saturated solution, which is B minus A, minus mass of the dry salt. Mass of the dry salt, we are trying to get the mass of the dry salt. Our mass of the dry salt was what? C minus A, which was C minus A. If you open this bracket, it's going to give us B minus A, then this is minus C plus what? A minus, and a minus gives us a plus. So this one and this one will cross, giving us B minus C as our mass of the solvent. So the mass of the dry salt is known. Now we want to know, this is the mass of the solute in grams. We want to know the mass of the solvent because we want to calculate solubility. If you want to get solubility, you get what 100 grams of that solvent dissolved. That is solubility of that salt. Now, if you have this one, this is the mass of the solvent. So here we are going to say B minus C, which is the mass of the what? B minus C is mass of the what?
The water.
Solvent, yes. B minus C. So this is the mass of the solvent. B minus C grams of the solvent, dissolved. What did it dissolve? What was the mass of the dry salt? It was C minus A. C minus A grams of the what? Of the salt. Okay, if not salt, it is a solute. So what about 1 gram of the solvent? What did it dissolve? It dissolved C minus A out of B minus C grams of the solvent, of the solute. Ask yourself, what did 100 grams of the solvent dissolve? It was C minus A out of B minus C times what? Times 100 grams from here. It dissolved this over this times 100 grams of the solute. This, if you substitute this and get that this mass in grams, that is the exact solubility of that salt in 100 grams of a solvent. At that stage, you have calculated solubility of that given salt. Now, let's look at an example for us to understand this. I know people are now writing, they are trying to absorb what's not there. An example is here. 30 grams of sodium chloride. Sodium chloride. 30 grams of sodium chloride. Crystals were dissolved in 75, were dissolved in 75 grams of water at 80 degrees Celsius. They are saying calculate solubility of sodium chloride at this temperature. If you want to say, if they tell you to calculate solubility of sodium chloride at this temperature, this one is easy as getting what this one, the grams of this solvent can dissolve at 100 grams. That is all. Now, when you start, you write a statement the other way around. 75 grams of the solvent, that was water, dissolved 30 grams of sodium chloride. What about 1 gram of water? What did it dissolve? To 30 out of 75 grams of sodium chloride. Now, what about 100 grams of water? What did it dissolve? It was 30 out of 75 times 100 grams. So what is this? The answer is what? 40 grams of sodium chloride. So 100 grams of water can dissolve 40 grams of sodium chloride. That is solubility. So the solubility of this salt will be 40 grams in 100 grams of water. That is solubility. So if you want this salt to dissolve, or if you want to calculate its solubility, get 40 grams, dissolve in this, that is all. Is it clear?
Yes.
Let me hope I'm not talking alone. Nantongo. Christine. Christine. Christine.
Yes.
Are we in the same class?
Yes, sir.
Good. Wendy.
Yes.
We are in the same class.
Yes.
Ready? Ready?
Yes, teacher.
Are we in the same class?
Yes.
Okay, that is good. Now, if you look at number 2, number 2 has a slight difference from the first one. The first one was direct, but number 2, there is some trick in number 2. It says 12 grams of potassium chlorate were carefully evaporated to dryness. So this is 12 grams of potassium chlorate were carefully evaporated to dryness. That means if it was evaporated, it was heat to dryness, meaning these 12 grams had even the mass of the what? The solvent. Thank you. So here, number 2, there was mass of the solvent. So the solvent plus the solute, all of them were there in the 12.0 grams. But now they have given us our solute. What is the solute? It is 2.4 grams of potassium chlorate. Potassium chlorate. This is the way you write potassium chlorate. Was left on the evaporating dish. Calculate the solubility of potassium chloride in 100 grams of water at room temperature. Now, if you know this, this is the grams of potassium chlorate. What was the mass of the solute? Of the solvent, I mean. What was the mass of the solvent? Yes, I'm waiting. Mass of the solvent is going to be 12.0 minus 2 point what? 4 grams. The answer is 'Phyllis. Phyllis, what is the answer? We are trying to get the mass of this solvent, which dissolve this. The answer is what? If you subtract 12, yes?
9.6.
9.6. Very good. So you write the statement starting with the solvent. You say 9.6 grams. 9.6 grams of the solvent. What was the solvent? Water. Dissolved what? Dissolved. What was the mass of the solute 2.4 grams of potassium what? Chlorate. What about 1 gram of water? It dissolved 2.4 divided by 9.6. These are grams of potassium chlorate. What about 100 grams of water? Because solubility is at 100 grams of water. 100 grams of water dissolved 2.4 divided by 9.6 times what? 100 grams of potassium chlorate. If you substitute this in a calculator, what is the answer you get? Esther, what is the answer? Esther. So after this 1 minute, we shall still use the same link to come back to our lesson and we proceed with the next number. The answer is
25.
25 grams. So when you write solubility, you don't write